Okay, everybody, here's part two. The mass and change big ideas. So we spent a few days collecting, between the collecting data and the talking about all of it. We spent a couple days doing this, and there are definitely some things that we need to be able to take away from this and file away and hopefully write down and remember. All right. So first of all, you were presented with 4 scenarios. Okay, so this needs to be in your notes. So you better be having your comp books out and writing this down because this is good stuff. I'm gonna give you guys some nuggets of wisdom here. All right, so big ideas. First of all, we had 2 different kinds of changes going on in this lab. All right, so does anybody know what 2 kinds of changes I'm talking about? 2 kinds of changes. Anybody know what I'm talking about? Well, physical. There were physical changes that happened. What kind of physical changes did we see? Well, let's see. Stretching out the steel wool. That would be a physical change, right? What would be another one? Oh boy. So stretching the steel wool, definitely a physical thing. It's still steel wool. Dissolving the sugar is a physical thing. Sugar dissolving. Now, the thing with sugar dissolving, it's still sugar. Okay, so those were definitely the 2 that were physical changes. Now, how can you tell a physical change from a chemical change? Well, let's see. If we look at a chemical change, here's what we'll do. Obviously, if the 2 I just mentioned are physical changes, then I'm probably leaning toward the other 2 being chemical changes. But how do you know what a chemical change is? Like, how can you recognize a chemical change? Well, let me on the side here. Let's see, evidence of chemical. Oh boy. Oh, this is terrible. Oh no. Oh boy, the eraser was too big. Oh my gosh, I got to redo all that. Are you kidding me? Evidence of chemical changes. All right, I'll make a little short list here. All right, number 1. All right, so we could have a change in color. Now, did we see that at all in this little lab? Well, the little balls of steel wool changed color after heating. Is that a possible evidence of a chemical change? It most certainly is. Let's see. We could have the production of heat and or light. Produce heat and or light. That would be an evidence of a chemical change happening. 3. How about fizzing and bubbling? I believe we saw that. Now, why would fizzing and bubbling be fizzing, bubbling? Oh boy. This writing is terrible. So fizzing and bubbling, which means a gas is formed. Gas forming. That's what that means. When you see fizzing and bubbling, there's a gas forming. Let's see, number 4. How about an odor? Sometimes there's an odor when you have a chemical change occurring. Some of you noticed, and I think in a class or two, we talked about how burning the steel wool, there was definitely an odor that was going on. And there was definitely some fizzing and bubbling going on with the Alka-Seltzer. There was a change in color with the steel wool. So if you look at this list of things here, now I guess I'll add one more to the list. New substances are formed. So that's kind of like, I mean, that goes with what we said about the gas. If a gas is being produced, that's a new substance that formed, but it doesn't have to be a gas. It could be other things that are formed, like rust on the steel wool would be an indication of a new substance. So anyway, this list here, an important list of evidences of changes that are chemical. All right. So back to our list here. If we're looking at the ones that were chemical change, well, then we're obviously looking at the Alka-Seltzer, and we're looking at the, oh boy, where was I? Oh yeah, possibly the steel wool. Could have been, oh boy, could have been a chemical change. All right, so we had two kinds of changes. There were physical changes and there were chemical changes. So what about that? I mean, who cares? So yeah, there's chemical changes, yeah, there's physical changes, but what does that have to do with what we're talking about? Well, we're talking about a system. In each of the 4 situations, we had a system. So what is the actual system? Well, the system, each part had a system. Oh boy, this writing is awful. Each part had a system. And so what is a system? The chemicals and the container. So when I talk about a system, then I'm talking about the chemicals themselves and the container. Both of those would make up what I would consider or call a system. So, how do we view mass then in terms of a system? There's something that is called the law of conservation of mass. So there's a law of conservation of mass. What does it say? Well, it says that in any change, I don't care if it's physical or chemical, in any change, the mass before will equal the mass after. Oh boy. Oh no. I'm having a hard time writing. So, in any change, the mass before will equal the mass after. Now, you had some changes here where that's not true. So, this was not true for all 4 parts for each of you. So, what do you do with that? How do you make sense of that? Well, here's the part. Unless particles enter or leave the system. All right. So there's the exception. The only time that the mass is gonna change in a system during either a physical or a chemical change is if the particles have either entered from the outside or have left the system. All right, they're either coming in or they're going out. That's the only way the mass of a system is going to change. It's not because of a chemical change, it's not because of a physical change. In either case, the mass before will equal the mass after, unless we have let particles in or out of the system. All right, that's the law of conservation of mass. Okay, just a couple more things here, and I'll wrap it up. So we've established then what chemical changes are as compared to physical changes, what we actually did in the lab, that in every case the mass was conserved. We had the same amount of mass after as we had before, unless we let particles into the system that we hadn't already accounted for, or we let particles escape the system that we had already accounted for. All right, so maybe at this point we should finally define this thing called mass. What is mass? How can we define what mass is? Well, all of you have been drawing these particle diagrams, and these particle diagrams are kind of telling us and showing us what mass is based on how you've been sketching them. And every time you've sketched a particle diagram, you've used particles to represent how much mass there was. If it was the same amount of mass, then you had the same number of particles. If it was a less amount of mass, then you had fewer particles. If it was more mass in the after measurement, then you had more particles. So, it sounds like that mass, the way we're working in class right now as kind of a working definition, is the measure of how many particles an object has. Or, I mean, you could say particles or stuff, I guess we could call it. Just how much stuff something is made of. Oh boy, I can't write. That's terrible. Stuff. That's a little better. All right, so how much stuff an object has, how much the stuff is made up of. All right. Maybe I should, oh boy, I should probably change that too. Oh, geez, you're going to be upset. So, an object is made up of, how about that? There we go. So this will be our working definition for mass then. All right, how much or how many particles an object is made up of, or how much stuff. All right. Going back to the other things we had just talked about, the exceptions to there are a couple exceptions to this conservation of mass, and it has to do with nuclear and quantum level interactions. And so for us, as far as we are concerned, mass is always conserved. The mass after a change is always going to be the same as it is before a change, unless particles have entered or left the system. So for us, that's going to be how we view things. That's how we've seen things so far. So there's just one last thing then. This is the last big idea. So mass is a major concept, major idea. Okay, chemical changes versus physical changes, major idea. How to be able to determine and have evidence of chemical changes, also a major big idea. The last thing is this. So not only have we defined what mass is, but we need to come to the conclusion that all matter is made up of what, do you suppose? With all this talk of particles, I hope that was maybe the word that was coming to your mind. This is part of what's called the kinetic theory of matter, right? And we're going to build this as we go the next few days. So all matter is made of particles. All right? Everything that is matter is made of particles. And therefore, all matter, since it's made of particles, all matter then has mass. Two really big ideas here that hopefully you'll be able to kind of wrap your head around. All right. So what is mass? The measure of how many particles something is made up of, or how much stuff an object is made up of. And secondly, all matter is made of particles, which therefore means that all matter has mass. All right. So that's going to be about it for this. The next thing we're going to talk about is volume. So we'll talk about that when I return. Hope you have a great rest of your day. Hope video 2 was exciting. Thanks. Bye.